Unit 2, Section 10.3 Worked Examples. Use the compound interest formula to compute the total amount accumulated and the interest earned. $2,000 for 2 years at 4% compounded quarterly. Compound interest formula is shown here. The principal is $2,000. The interest rate as a decimal is 0.04. Number of compounding periods per year is 4, compounded quarterly, and invested for 2 years. So I've taken those amounts and I've put those into the formula, and I went ahead and I simplified the exponent. 4 times 2 is 8, and I'm going to show you how to work this problem in the calculator. And the first thing you want to do in the calculator is to work on this portion here inside the parentheses. Remember, order of operations, we always go in the parentheses first, and we're also going to do the division first. So if I pull up my calculator, the first thing I'm going to do is the 0.04 divided by 4, 0.04 divided by 4, and then I'm going to add 1, and then I'm going to raise to the exponent, and remember the exponent here was an 8, and here's my exponent key on my calculator. I'm going to raise it to the 8th power, and then I'm going to multiply by the principal, which was $2,000. And so the amount that will be earned or accumulated is $2,165.71. So the total amount accumulated is $2,165.71. And the interest earned is the accumulated amount minus the amount that we invested, which was $2,000. So the interest is $165.71. Determine the effective annual yield for $1 invested for 1 year at 5.5% compounded semi-annual. And here's the formula that we use for the APY, the annual percentage yield formula. And our interest rate is 0.055 as a decimal, and it's compounded semi-annual, so N is 2. And I'm going to go ahead and work this formula in my calculator. And again, I'm going to start inside the parentheses. And I'm going to take that 0.055 and divide by 2. Add 1. I'm going to raise it to the exponent of 2. And then the last thing I always do is subtract a 1. And so the effective interest here is actually 5.58%. 5.58% as compared to the stated interest rate, which was 5.5%. So the yield is always going to be slightly higher than the stated rate. Use the present value formula to determine the amount to be invested now or the present value needed, and we wish to accumulate $60,000 after 13 years invested in an account with 3.3% compounded monthly. Here's my present value formula. The amount I'm going to invest is $60,000, interest rate as a decimal 0.033, compounded monthly, 12 compounding periods per year for 13 years. I've put the numbers into my formula. I went ahead and I simplified my exponent. 12 times 13 is 156. Now in this case, I'm going to be dividing by a number, so if my calculator has the ability to store things, that would be very helpful, because at the very end I'm going to take the 60,000 and divide by the quantity that I calculate in the denominator. And so I'm going to go ahead and again start with the 0.033 and divide by 12. Add 1. And then I'm going to raise it to the exponent, which in this case is 156. And then again, notice I'm going to be dividing that number into 60. Now my calculator here has a memory, and so if I go ahead and I put this into memory plus, it's going to store that number in the memory. And I'm going to go and say 60,000 divided by, and then I'm going to hit memory recall. It's going to pull up that number I just calculated, and there's the final answer. There's the amount that we need to invest now in order to have $60,000 after 12 or 13 years rather. So we need to put in 39,000 $39,092.61.